Hello my 12th standard warriors, welcome to the Pathfinder series, which is nothing but a 12th standard long-term course on Enthuse. And today is the first class of alternating current, and we have all studied DC currents and voltages where you connect a battery and the current flows only in one direction. But imagine a source which can alternate between the directions in which it supplies the current, like shown in the diagram. In this animation, you can see the current changes its direction, and that's what is alternating current. And we are also going to see how alternating current is produced and the different parameters like RMS, average, peak, and also the phasors associated with AC circuits. So all of this with me, Shreyas, your physics master teacher at Vedantu, and I'm going live. Welcome to Enthuse, one of the special exclusive English medium channels of our country. And I'm Shreyas. I've been teaching for a very long time, and not just on YouTube, but also, on the regular paid platform. And before joining Vedantu, I was associated with a lot of renowned names that you can think of offline industry. So welcome aboard, and the only aim that I am over here is because I want you guys to excel in your ranks, in your marks, in your percentiles next year. So this is the 2022 batch, which is also called as the Pathfinder series. And if you want to know more about me, you know where to go. You can just visit my Instagram handle. And this is the schedule for this week. So please take note. The ones in white are for you guys. That's 2022 students. That's the first class. This is the second class, this is LCR series, and this is the third class, resonance, quality factor, power factor, and transformers. That's going to be on Friday. This is on Wednesday. This is today. And if you want to attend advanced classes for the outgoing batch, you are allowed to do so. You can freely attend that. These are the advanced classes, okay? And these are the 11th standard classes for the nurture students 2023, okay? And some more classes might also turn up. And remember, I always post all my updates and all the important notifications on the Telegram channel. So in case you have not yet joined, please check it out, guys, the Telegram group. There is a link given in the description box below. Hello Aniket, Sidhu, welcome Gautam, the unknown, hello Balaji, hello Khan, hello Scientific, Ashif, hello Archana, hello Karthikeyan, welcome aboard. Hi Aishwarya, good evening, my bacha log. Welcome. Hi Nikhil Krishna, hi Uncharted, long time no see. Hello EGL, hello Aniket Sinha, welcome aboard all my lovely warriors. And yes, before we forget, do not forget to smash the like button out there, because that's how you show your support and your love to us. And also do one favor, in case you are new to our channel, you know what to do, go smash the subscribe button as well, in case you have not yet done. Hello Sapti, finally you are on time. Hi Survi, welcome aboard. Thank you Gautam. All right. So, oh my god, by the way, there is a special news today that I want to give it to you. I think I should break it. Yes, we are all warriors. Now, see guys, some of you do not know that there is a Vedantu batch starting this Monday, okay? A short-term batch, because the long-term batches, started in June, July. But in case you have missed the bandwagon, don't worry, there is like a bigger crash course. It's not a crash course, but it's not a big course. So to complete the syllabus within the next few months, there is something in between, okay? It's like a fast track kind of a batch which is about to start. So please check those details out, because all these amazing results that you see from Vedantu should probably give that confidence that yes, if my coaching institute is not capable or sufficient enough to help me out with the ranks, then it's okay to join another institute. It's perfectly fine. Even if you lose all the money, it's okay to join, some institute, or follow those teachers with whom you are comfortable with, and also where you have a lot of faith. So, Vedantu has been producing like really amazing results. That's why I always tell my students, guys, I mean, why I have this faith and why I have this confidence whenever I tell that, guys, there is a course starting. I know for sure, it doesn't matter which teacher he learns from, which batch he is in, he's going to excel in his studies. In fact, 4 out of 5 students were already qualified for JEE Advanced from Vedantu right till 3rd attempt. After 4th attempt, this number is going to increase even further. and there are so many students in 100 percentile region as well. Now, not just that, okay, the courses are very affordable and you get a lot of facilities like doubt solving, Tattva module, test series, assignments, live classes, recorded classes. If you want personal mentorship, you go for the plus. If you want, the classic version, then you go for the, if you want doubt solving, then you go for the, classic version. And these courses are hardly for 3,000 rupees per month. Okay, they start around 3,000, go up till 5,500 roughly per month, and you can also avail the EMI option. But the best part that today I want to tell you guys. Hi Surya, welcome aboard. How many of you know this? That there is a batch of mine starting this Monday for 12th standard and also the dropper students. Guys, you heard it right. Problem solving sessions. Final announcement coming up. Actually, thank you Kumar. Here. So there is a special class for KVPY physics also. There is a batch which is going to start live classes. These are not recorded. I mean, recording will also be done in case you want to watch it again, obviously, or you miss it for some reason. But these are live classes. You get to attend my classes live in the Vedantu platform, and that is the micro course of mine which I'm starting this Monday, right from electrostatics, capacitors and current electricity. Problem solving sessions. Complete details will come up very soon. In fact, I'll post it on Telegram also if you want to. But guys, this is something that you don't want to miss. So go ahead, check out the link which is there in the description box below. Join the pro subscription. My course where you can enroll is completely free for all the pro students. Whether you take light, classic, plus, really doesn't matter. Okay? But it is free once you are in the pro subscription. Isn't it exciting? Isn't it exciting? Yeah. Jaddu beats, I would love to take for 8 hours, but then your concentration level won't be there for 8 hours, number one. Number two, it's not good for your eyes, alright, when you sit for a very long time. That's why generally we prefer taking classes for 1 to 2 hours, which are comfortable for your eyes. Number two, you cannot sit in a class for 8 hours. I mean, it's good when you have it like a recording. In recorded class, fine, you can watch even a 20-hour class. You can watch it for 1 hour by taking breaks, but continuously live class, it's not recommended for eyes as well as the brain. Yep. So that's how it is. So guys, I would be very, very eagerly waiting for all of you out here in the course that I'm starting this Monday. This is for 12th as well as dropper students. This course will be in English, okay, obviously, and who can get to interact with me. That's what the specialty is. Oh, by the way, I'm going to give assignments. If you're thinking it's just a class, no, I'm going to give you assignments. A lot of my personal problems are going to be there in that particular session series. Okay, so see you guys there. Okay, let's start with AC generation right now. Okay, now yeah, I'm always concerned about every aspect of you, Tarun and others, be it health, be it mental health, be it your academics. The only thing that runs in my mind half the time is what is going to happen with you guys and how to take care of you. Okay, now what is AC? How do you generate AC? It's very simple. Make use of Faraday's law. That's it. Now what is Faraday's law? It says that when you have a coil or a conductor and the flux through it changes, then you will see there is an induced EMF. Now that magnetic flux can be changed by a number of ways, because magnetic flux is dependent on the field, it also depends on the area, it also depends on the angle at which the field intersects the area. So how about creating a magnetic field using permanent magnets, taking a coil and rotating that coil inside that magnetic field? What do you think will change? Think, out of magnetic field and area and the angle between the field and the the coil, what do you think changes? Is it the magnetic field through the coil changes? Is it the area of the coil changing? Or is it the angle which the area vector is making with the magnetic field changing? Vikram, join in, bacha. I just started. In case you have missed the major announcement which I just did some time back, you can replay back the session and you can watch it. Yes, the angle is changing, and because the angle is changing, the flux is changing. And the moment the flux changes, because as the angle changes, the number of lines passing through it will change, okay, and that's how the flux changes. And the moment the flux changes, you will see there will be induced EMF inside the coil, and that's what creates that EMF. So look at this. This is a simple generator. You might have seen a generator, a diesel generator, or you might have seen just a normal generator or a dynamo, what it is called, in many different places. What is there in a generator? You have magnets which create magnetic field, and there we go. All right. So we have magnetic field like this. Let's say I call it B, and there is a coil which is made to rotate using either an engine or a motor or a turbine or something else, something which will rotate it, or you power it up using some external mechanism. And this coil will obviously have some area vector, I'll call that A, okay, and the angle between them is, let's say, theta. That's the angle between area vector of the coil and the magnetic field between those two poles of that magnet. Now, what is the flux associated? The flux in the coil. The flux in the coil is BA cos theta, but there could be many turns, so I will put N to just signify if there are more number of turns, then you just need to multiply it by N. That's it. Now imagine this coil, all right, imagine this coil is rotating with angular velocity omega. Imagine this coil is rotating with angular velocity omega. We all know one thing, angular velocity is angular displacement by time interval. Angular velocity is angular displacement by time interval. Let's say, for example, initially the coil was perpendicular, area vector was here. After some time, the area vector turns here by some angle theta as shown. So the angular displacement, isn't it theta, guys? Okay, initially it was horizontal, after some time it is theta. So, it is theta in how much time? Let's say t time. So from this, I already know what is the value of theta over here. So it will be BA N comes here, cos of theta. What is theta? It is omega into t. So I can just put it as cos omega t. Everybody fine till this point? Everybody fine till this point? Clear? Okay. So theta was the angular displacement and t is the time taken for it. Okay, so omega is theta by t, so theta is omega into t, which I have substituted it over here. Good evening, Sri Janani, welcome aboard. Okay, Surya will take more classes, bacha, and also some backlog sessions. Okay, so because this is the last chapter of term 1, do you realize that? We are done with term 1 syllabus already. Yeah, after this chapter it's done. This is the last chapter of term 1. Okay, now what you need to do, this is the flux. By Faraday's law, using Faraday's law, I can say the induced EMF is minus d phi by dt, which is minus BAN are constants, so I'll just put it outside. So inside my derivative, I just have derivative of cos omega t. So therefore, it will be minus BAN. Now the derivative of cosine omega t is minus sine omega t, and whatever is there as a multiplying factor with the variable that comes outside. So into omega, do not forget that omega has come outside. So minus minus gets cancelled and you will finally write it as BA omega n sine omega t. So that is the induced EMF. So very important formula, and you should remember this. This is the voltage which is generated across the two terminals of that coil which is rotating. Now, here is the logic. See this BA omega n, let me just mention it for you guys. This BA omega n, this is a constant. This is a constant. Sine omega t, okay, this sine omega t, this is an oscillating term. It sometimes becomes positive, it becomes 0, it becomes negative. So this value on the LHS, constant into a variable term, sine varies, plus 0, minus 0, plus minus 0. It keeps on oscillating. So this value also will become plus 0, minus, again 0, plus 0, minus. It keeps on changing. And we all know what is the maximum value of any sine. The maximum value of any sine is 1. And the least value is minus 1. So the max value is plus 1, least value is minus 1. So the max value of induced EMF will be plus BA omega n, and least value will be minus BA omega n, which is that constant. Everybody agrees to this? Sine of 90 is 1, sine of 270 is minus 1. So those are the max and the least values of sine. Hence the max and the least values of this LHS, which is the induced EMF, will be BA omega n and minus BA omega n. That's it. Perfect. Great. So this is nothing but sometimes my voltage is positive. Voltage is positive means what? This is, this is positive, this is negative. So the current will flow like this. Okay, the voltage is positive. For example, the current will flow like this. Sometimes the voltage is negative. If the voltage is negative, meaning this is minus, this is plus. So the current will flow like this. Don't you see? There are two ways or directions in which the current flows through this device. Once it flows like this, other time it flows like this, again it flows like this, again it flows like this. So the current is changing the direction as the sign of this value changes, because this won't remain shant, it won't remain chup, it won't remain quiet, because this t will keep changing, this value will keep changing, this sign will keep changing, so the direction of current will keep changing, and that's why this is an AC, or basically alternating. It keeps alternating. It's an alternating current. I hope this is clear. I hope this is very clear. Yep. So EGL, the constant term, because B is constant, area is constant, omega is constant, N is constant. So total term is also constant. So constant into 1, 1. Constant into minus 1, minus constant. That's it. That's all I have done. All right. Very good. So that's all it is. Very good. Very good. Thank you, Jagdish. Welcome aboard. And yes, please be regular, guys. Yep. So in case you have some doubt, Jagdish, about some options, how about leaving a comment after the video ends? I'll definitely reply to you. Okay. Chalo. So showing over here, whatever we have derived, the EMF induced is born. Okay. There is a very easy way to remember that. Mnemonic. How to remember born? Born identity. Bohr-Born. Everybody has had that Bohr-Born biscuit. So don't remember Bohr. Okay. Just remember Born. Bohr-Born. B A omega n. B is magnetic field. A is area. Omega is angular speed, N is number of turns, sine omega t. Does it matter if it is sine or cos? Well, it really doesn't matter, because if it is sine or cos, all it tells you is where was the coil located initially. Doesn't matter. Sine graph and cosine graph are just shifted by 90 degrees, so it's really okay, even if you use cosine term. Okay. So obviously, if you want to crack advanced exam, apart from my videos, you need to also solve questions. Just watching my videos won't be enough, right, bacha? Nothing will be enough. Okay, so this is how it looks like. Now let me show you how the generator looks like. Okay, I have a nice simulation out here. Let me just see if I can bring it up. Okay. All right, and there it is. Yep. Okay, just look at this. There is a tap. Water will fall on this. This is a turbine. It will rotate. This is a magnetic field. There is a coil. And let's see how the current looks like. Okay, let me just open this tap up. Okay, let me see if I can get this tap moving, guys. Okay, yep, I should be able to move this tap. Oops. Okay, maybe I'm not able to touch it and move it. So I'll just move it over here. Yeah, there you go. So I'm able to move it. Yeah. So you can see this is rotating. As it rotates, Look at this. Let me just see if I can show the field. Okay, let me just click it over here. So this is the magnetic field. You can see this is changing, but not so much. So let me do one thing. Let me increase the strength of the magnet. Let me increase the strength of the magnet. Now probably you can see that this arrow mark is shifting left and right, because the magnetic field is strong. The magnetic field once goes here, once goes here. So there is alternating current. Current goes once like that, once like this for every rotation. If I increase this valve's opening, it will rotate faster. Okay, the frequency will increase, and you can see it goes back and forth very frequently. Yeah, once it goes like this, once it goes like this. There is one more thing I can do. I have a control for changing the loop area as well. If I increase the loop area, you can see that. If I increase the loop area, then more flux will pass. If more flux passes, area increases, more fast will be the rate at which the flux changes. So EMF induced will also be more. So EMF induced is also more. I can increase the area even more if you want. Okay, I can make it like this big. So the voltage, you can see it is changing by a lot of amount. Isn't it interesting, guys? Also, I have an option to increase the number of loops. Observe, right now there is only one loop, guys. So how about making it 2 loops? Oh my god, look at this. The moment I make it 2 loops, the voltage also increases tremendously. If I make it 3 loops or something like that, I'm pretty sure it increases even more. Oh my god, look at that. That is significant increase. I can only increase it till 3. So that's a big amount of increase. Okay, and I can also change the water flow, and if I make it go really fast, my god, this has gone bazooka like. Yeah, it's crazy. Look at this, the way it is changing its voltage. Okay, so this is how a generator works. Okay, so usually you have some, this is how hydroelectricity is generated. Okay, you can also attach a petrol or a diesel engine here and make this rotate, so that and the thermal energy will be converted into mechanical energy will be converted into electrical energy. If the water falls, potential energy of the water is converted into kinetic energy for this turbine, and finally it is converted into electrical energy. So these are the different ways in which you can generate electricity. Okay, so this is how a generator works. Wasn't this cool? Yep, very good. Okay, EGL, my god, what is EMF? Bacha, EGL, I think you are in lower grades, so you can do one thing, Bacha. Just watch my previous lectures. You need to watch it from the start, because right now we have moved very much ahead of what is EMF and what is flux. I have explained all of this, in my previous chapters of EMI and current electricity. So please check those lectures out. I'm pretty sure once you see those lectures, you will understand what EMF, what flux is, and all of that. Okay, everything you will understand. Okay, Vikram is saying save water. Okay, don't worry. By the way, this water is not wasted. Anyways, that water was flowing. I'm just putting a turbine. The water was anyways going to fall. So I'm just making use of that water which was going to fall. I'm making use of that energy. So actually water is not wasted. Okay. Chalo. Let's move to the next one. Now the graph will look something like this. The graph will look something like this. Look at this. This is a sine or a cosine graph. Okay. So the voltage will increase, decrease, because it's a sine term. We know how does a sine graph look like. A sine graph looks like this. So when you multiply it with this number, instead of +1 and -1, remember everybody, sine graph, how does a sine graph look like? The sine graph starts from 0, goes like this. This is +1, this is -1. So instead of +1, -1, you will have plus a bond and you will have minus bond over here. These are the maximum and the minimum values. I hope this is making sense. Okay, so this is how the current or the voltage changes. Great. All right, Ishwar. Yep, Satvik, they are not wasting. Correcto. All right, Archana said it was awesome. Nikhil also loved it. Glad. Okay, let's get moving. Kritik also liked it. Looks like it. Okay, everybody is clear about this graph. Then let's move ahead. So this is how the voltage is created. It's an alternating current. Generally, this is called as the positive half cycle, half of that complete cycle. This is called as the negative half cycle. That's all. Okay, positive half cycle, negative half cycle of the AC voltage. Now there are multiple parameters that you should know about AC. First one is the peak voltage. So what is this peak voltage? Like you can see on your charts, what is this peak voltage? Peak voltage is nothing but the maximum value or the amplitude. Like you can see over here, this is the amplitude. So imagine, when you have a sine or a cosine voltage, okay, doesn't matter. If I say I is equal to I naught sine omega t, this is nothing but the peak or amplitude of that voltage. Amplitude, you have heard this in waves, you have heard this in simple harmonic motion and so many other places. So it's the extent till which the parameter or the value changes on either side. So if it was 0, it goes till here and it goes till here. So this is nothing but the amplitude. If I write V is equal to V naught cos omega t, then this will also be the peak or the amplitude. Okay, doesn't matter whether it is sine or cos. So this is the peak or the amplitude. Here this is called as the peak voltage. Here it will be called as the peak current. Doesn't matter whether you use it in reference with voltage or whether you use it with reference of current. It's just the maximum value or the amplitude. That's all. Okay, so the instantaneous value of any current or voltage will be some sine or cosine. So that I naught is the peak value or the amplitude of the AC current or voltage. All right, next parameter, if everybody is clear about this peak, this is very simple. The next one is really interesting, and the next one is nothing but Uma, join in bacha. Hi Bala, welcome aboard. Yes, join in. Ria, that's very cool. Ria, 160 in physics in 2021 NEET. That's stupendous. Look, very good. Congratulations. Hi Hariharan, very good. Welcome aboard. What is average? See, I'll tell you what average is. In general, let's say, my voltage changes like this. Now my voltage is this one at some time, okay? At some other time, this is my voltage. At some other time, this is my voltage. At some other time, this is my voltage. So what is the average voltage? The average voltage is value of voltage now, then value of voltage then value of voltage next instant, plus there will be n number of terms divided by the number of terms over here. V1 plus V2 plus V3 plus V4 plus number of values upon the total number of values. But the problem is when you have a continuous graph like this one, okay, or this one, then the number of values that you will take will also be infinite. Does it make sense? So the number of values that you are taking will also be infinite in number. So in that cases, you do not have this definition. So when you have discrete, everybody knows what is discrete. Discrete values, when you have discrete values, the average of anything is V1 plus V2 plus Vn, the whole thing divided by n. But the moment it becomes continuous values, okay, what is the meaning of discrete? Discrete means, I tell you, at time t1 value is v1, at time t2 value is v2, at time t3 it's countable, okay, the value is v3. You can count the number of values, then it is discrete. In continuous, every instant, dt instant, it keeps changing. That's a continuous. Then the formula is slightly different. You will learn the formula for average in maths as well. You are going to see what is the average value of a function. Average value of any continuous function or continuous values are given, then it is integral v into dt, the whole thing divided by t. This is definite integral from 0 to t. This is what is the definition when it is a function of time. Okay, when it is a function of time. Now there is a very simple logic to this. See guys, imagine for example, this is my voltage function. Imagine this is how my voltage changes. Okay, this is my voltage function. So this is my voltage function, which is some function of time. This one, okay. Now, if I ask you what is the area under this graph, okay, what is the area under this graph? What will you say? The area under voltage versus time graph, it will be nothing but integral the function, which is voltage, with respect to time from 0, let's say this is t, 0 to t. This is definite integral, everybody knows this, integral v dt from 0 to t. Very good. Now, if I ask you, find one value of voltage whose area under the graph in the same time is same as the area under this green graph. Find one constant value whose area is same. That means, look at this graph. Look at this graph. Okay. So, whatever area is here probably just fits in over here. It just fits in over there. So, the total area of the red graph is the area of the green graph. So, it's basically, let's say, area under, the constant voltage versus time graph. Let's say it is equal. Now think, what is the area under this red graph? Area under the red graph will be height into base. What is the height? I don't know. The base is nothing but t. This height of that constant value which gives you the same area, as that of the variable graph, this value is called as the average value. Yes, so this is nothing but average. Now only thing you need to do is shift this time below, and what you will get is exactly this value, average value. So this is how average value has been derived. So what is average? Average is nothing but that constant value which gives you same area as that of a variable graph. Okay, so when you measure the area of this average graph, it's the same as that of the variable graph. That constant value is called as the average. So when you shift the time over here, this is the formula that you get. As simple as that. Guys, now you understood it? All right. I hope this is clear. All right. Very good, very good, very good. Ria, no problem, Bacha. I'm so glad you were able to attend at least till now. And don't worry, once a Vedan, you're always a Vedan. And we will keep supporting, loving you guys. And I hope you will also support this channel and recommend this and to your juniors and your friends as well. Okay, chalo, let's get moving. Now, once you understand this concept, think about it and tell me very quickly, if I have a sine graph or a cosine graph, what do you think will be the average value of this function? Quickly tell me. Winbone, yes, it's been a while. Victor Invitia, which chapters of 11th are needed for 12th? I have made a video for that. Check it out. Just search for Strategy JEE 2022 Shreyas Sir. I hope you can do that on YouTube. Just search it. I have listed all the chapters and the chapters which you can study with 12th standard. What do you think will be the average value? Very good, Nikhil. Very good, Winbone. Very good, Uma. Very good, Janish. The answer will be 0 because this area and this area will be same. So the total area will be 0. If the total area is 0, basically this numerator will be 0. If numerator is 0, average is 0. So the average value will always be 0. Very good. Very interesting. Excellent. So that's what average is. Average is nothing but, let me just put it over here. Yep. 1 by t integral 0 to t I dt. If this is current, if this is voltage, then you will put V dt, and here this will be V average. That's it. Keep this in mind. Okay. This is how you do it. Okay. Very, very important formula. All this is going to come up in your notes, guys. Next thing coming up on your screen. Okay. Let's move ahead. Okay. Yep. Now, next is RMS. Yep. RMS. Now, how do you find out what is RMS? If you're cleared, means you should definitely give advance. It will be interesting, Ria. You never know what might happen. So please give advance. I'm pretty sure something good might turn up. So there is no harm in preparing for advanced. Yep. So Sangeeta S, if you are in 11th standard, probably this lecture is not for you because this is one of the last few chapters of 12th. Number 2, we have a nurture series. So you can check out our Telegram channel. There is a Telegram group link. I update the schedule. Also on our community page, I have uploaded it. You can see there are many tabs, videos, home and all of that about me. Community. Check the physics timetable. You will see 11th standard classes over there. Please attend that. Those are for you guys only. Okay. Now, what is the meaning of RMS? You would have heard about this term RMS back in kinetic theory of gases. So, the same thing is over here. Now, I'll tell you what it is. Imagine you have a resistor. Okay. You have a resistor and you are passing some current through it. Let's say that current is variable current. Okay. So, this is AC current. Okay. So, that means this current will continuously change with time. Right? So, this current will change with time. Similarly, you have the same resistor, but in this resistor, you are passing DC current. DC current means constant current, right? Constant current will pass. This will also create some heat. This resistance will also create some heat. Everybody agrees with this point? Both these resistors will develop some heat. Now, imagine if I ask you a situation where AC current is passed, DC current is passed, but both of them develop the same amount of heat. So the amount of heat developed here, or the power loss which is happening here, okay, the power loss which is happening here and the power loss which is happening here, if it is same, then how much current should I pass? How much current should I pass in this DC so that the power loss in DC is same as power loss in AC? That current is called as RMS current. So what is RMS current? RMS current is that constant DC current that one must pass through the same resistance in the same time so as to develop the same heat as developed by a AC, which is a variable current. So how much heat a variable current develops, the same heat a constant current develops, that is basically your RMS current. I hope this is clear. Alright. Yes, Sri Janani Prabhu, you can definitely crack NEET 2022 because physics is same. So now, what is the power loss in case of, you know, let's say for example, AC current, and okay, let's do that. So the power loss will be nothing but, you know, I squared R, okay, I is a function of time, and if I tell this is nothing but dq by dt, because this is power loss, I'll get dq by dt is equal to I squared R. This is power loss. Okay. Now over here, the same dq by dt, okay, this will be equal to I RMS square into R. All right, fine. Now think about it. Let me just move this around, and what I will get is nothing but I squared R, because dq by dt and dq by dt will be same, will be equal to, or I can do one more interesting thing. I'll just do one interesting thing. Just take that dt over there. So I'll get dq is equal to I squared R dt. Integrate both sides. Okay, integrate both sides. I will get the total heat developed in a time interval or from some time. So this will be equal to R comes outside because it is a constant, integral I squared dt from 0 to t. That's what I will get over here. Now the same thing if you do on this side, okay, I will get dq is equal to I RMS square into R into dt. When I integrate, remember, I'll put the integral here because R and IRMS both are constant. RMS value is a constant value. Integral of dq is q. This will be I RMS square into R into t. Now what is RMS? RMS is that current which produces same heat in the same time. Okay, this time is, let's say, t. Yes, 0 to t. So in the same time it should produce the same heat. How about equating both of them? If I equate both of them, see guys, what is going to happen? Just equate both of them. R and this R will cancel, and what will I get? I will get IRMS square is equal to integral I squared dt from 0 to t divided by this t. So that's it. This is the formula that I wanted. The square of the RMS is 0 to t I squared dt by total time. That's what is the value of the RMS current. If you want RMS current, then take the root of it. That's it. So that's the definition, RMS current. So IRMS is nothing but root of integral 0 to t I squared dt divided by time. So there is square over here. So that's why root of the mean of the squares. So squares ka average, you can see squares are averaged and the root has been taken. That's why that name has been given as root of mean square. Surya, obviously this is in JEE. This is a part of JEE mains and JEE advanced both. Obviously, if somebody has not taught you or somebody has told you it is not important, then they have lied to you. Okay, these questions have come in the 4th, 3rd, 2nd, 1st attempt as well. Okay, Dhirendra, this is an English channel, bacha. Okay, so keep this in mind. This is something which you should know. What is RMS? So RMS is nothing but that constant current which produces the same heat as that of same constant current which produces the same heat in the same time as that of the varying current. So this is a derivation of that. This is what you get. Now, once this is clear, let me tell you, if for example, I is equal to I naught sine omega t, then the RMS current, which is by definition root of I squared dt divided by t from 0 to t. If you substitute this current and integrate it and find it out, the answer of this value comes out to be I naught by root 2. This is also something which you should remember. Okay, the RMS value is the max value or the amplitude divided by root 2, something which you should be very, very clear. Yep. So very important, peak by root 2. Now remember one thing, whenever they say, oh, that AC voltage is let's say for example, I don't know, 500 volts. It is 500 volts. What exactly is this 500 volts? This 500 volts is not peak. It's not average. It's always RMS. So remember one thing, whenever they give you options, question mein values, if it is not specified what it is, it always means RMS values. So the household electricity, how much voltage it is? Let me see how many of you know this basic general knowledge question. Yes, so Sri Janani, when they give you problems, remember all the problems will have RMS values. Okay, that's number one. Number two, RMS value gives you the idea of how much heat will be generated, in a circuit. So if you convert it into DC, this is the equivalent current of DC. Think of it that way. Yes, it is 220 volts. It's around 220 volts, correct. So the RMS value is 220 volts. So RMS value is I naught by root 2 or VRMS is also V naught by root 2, assuming, it is a pure sine or a cosine voltage. Also remember, RMS current is that current in DC which produces the same heat loss as that in DC. So that's the application. Yep. So yes, correct Janish, 50 Hertz is the frequency, 220 volts approximately is the RMS value. So the peak value will be more, remember that. So if somebody asks you what is the peak value, so this is 220, this will be V naught divided by root 2. So the maximum value will be 220 root of 2. So the max value will be more. So that will be 220 root 2. The RMS value will be somewhere here. Understand? It will be less than the max value. Keep this in mind. Okay. So very important thing which you should know. Okay, let's start solving some questions. 220 is decent. I mean, it's high for human body, but for appliances, it is perfect. Okay. Chalo. Let's see if we can solve this question, guys. Yes, Zayed, your messages are visible, bacha. The peak value of alternating EMF is given by this much. So, let's see if you can find out what is the instantaneous value. Okay, come on, guys, solve this. Let's see if you can get this. Shivami saying C. Well, the correct answer is actually C. Very good. Proud of you, my bacha log. Manisha, you can post your comments, doubts, okay? After the videos over in the comment section, I'll definitely respond to it. So use this function. E is equal to E naught. It is clearly mentioned 10 volt is the peak value. So what is the peak value? The peak value is 10 volts. So it is clearly mentioned. So it is 10. So that is E naught. Sine and frequency is 50. So omega is 2 pi f, which is 2 pi into 50, which is 100 pi. So omega will be 100 pi. Time is 1 by 600. Okay, 100 goes, so this will be 10 sine pi by 6, which is sine of, oh sorry, it is cos, my bad, it's not sine, it's cos, not sine. So I just put cos over here. So cos of 30 is root 3 by 2. So 10 into root 3 by 2, which is nothing but 5 root 3 volts. So what it tells me is, in that cosine graph, cos graph will be like this. At certain instant, what is the time? When the time is 1 by 600, at that instant, the value of the voltage is 5 root 3 volts. That's all it is saying. Very good. Excellent. Very good. Let's get moving to the next question coming up on your screen. The equation of an AC voltage is given by 100 sine 100 pi t volts. Then its peak value, RMS value and the frequency are. Okay, this one is straightforward. First of all, what is the peak value? The peak value is nothing but the amplitude, and the amplitude is going to be obviously 100 volts. Obviously, you can see that 100 volts is over here, it's getting multiplied over here. Next, okay, if I ask you what is the RMS value? RMS value is nothing but the peak value divided by root 2. So it will be 100 divided by root 2. Now you should know the value of 1 by root 2, guys. It is 0.707. Okay, 0.707 is the approx value of root 2, 1 by root 2, sorry. So this will be into 100, correct? So this will be nothing but 70.7 volts. So that's something which you should know. Okay, lastly, the question is, what is the frequency? Now for this, remember 100 pi is nothing but omega, and omega is 2 pi f. So from this you will get f is pi goes 100 by 2, correct, which is nothing but 50 hertz. That's the answer. So 100 volts, 70.7 volts and 50 hertz. That's the answer. Beautiful. Excellent. Excellent. So many of you got it. Very good Shivami, very good Nikhil, very good Uma Maheshwari. For NEET 2023, I am not teaching Hari Kishore, but there is a course of mine which is starting next week, Monday. So when you join that course, you will be able to attend all the courses that I have conducted. These are problem solving courses, HC Verma discussion courses, derivation courses, and also some of the live courses which I am taking. Okay, so all of that you will be able to access it for free. That's how it works. Okay, let's move on to the next question. The answers are correct. Here it comes, guys. Let's see if you can solve the next question coming up on your screen. The equation of an alternating voltage applied is this much. A hot wire instrument is used to measure the alternating voltage. The reading shown by the instrument is number 1. Number 2, what would be the reading shown by galvanometer? Very beautiful question. Let's see how many of you can solve this. Hello Shalini, welcome aboard. Come on, my warriors. Let's see how many of you can do this question. Amazing question. Many people are going to struggle over here. Now, what is the meaning of this hot wire instrument? Okay. So there is this voltage which is applied, and that voltage is given to be 311, okay, and that is sine 100 pi t. Now when I say that, this value is basically 311. Okay. Now what is the meaning of this hot wire instrument? Okay. So EGL, just post up a comment after the video ends. Probably I'll help you, or probably towards the end, just ask me. Let's continue with the flow. Hot wire instrument is that instrument which measures voltage or current, okay, voltage or current, basically in amperes or in volts, based on heat based on heat. Now, which is that one parameter which is dependent on heat? Come on guys, you should know this. Is it maximum value? Is it RMS value? Or is it average value? Which parameter depends on that heat produced? Come on, let me know in the chat box. Is it peak? Is it RMS? Or is it average? Think about it. Archana is saying 219. Let's come to that. Let's see. It is the RMS. So a hot wire instrument which is based on the heat developed and it measures either voltage or current, it measures always the RMS value. If you know this theory, that's it. You now know what to do next. So it is maximum, which is 311 divided by root 2. So just multiply this 0.707 into 311. Approximately it will come out very close to 220 volts. Very close to 220. Maybe it might be 219 point something, but yes, 220 volts is roughly the answer. Very good. Average, na Shalini. Remember, RMS current is that DC current which produces the same heat as that of the AC current. So that wire will create some heat, you measure that heat and then you will expect, Achha, how much heat will be created in a DC current? Okay, so you will find out the DC current using that heat formula. So understand, you are indirectly measuring RMS. So that's why that heat produced is indirectly measuring RMS value. Alright, now galvanometer. What is this galvanometer going to do? Think about it. Galvanometer measures deflection which is directly proportional to the instantaneous current. Instantaneous current. Now here comes the problem. Guys, this is AC current. This is AC current. Now if this is AC current, what will the galvanometer do? Remember, there is a torque produced due to the magnetic field. So the deflection will go like this and like this, like this and like this, like this and like this. So it will keep going like this. It will keep going like this. Everybody agrees? The galvanometer would want to go like that. But there is a problem. What is the problem? Look at this frequency. 100 pi. 100 pi means frequency is 50 hertz. So 50 times in 1 second. Tuck, 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 tuck. By the time the current goes here, by the time the galvanometer's needle decides, okay, I want to go this way, by the time the current would have already changed the direction. Then by the time the galvanometer's needle will be like, okay, I'll go this way. Like, no, wait, we are now going this way. Then, okay, needle will be like, okay, I will go this way. The current has already changed the direction 50 times in 1 second. Keep this in mind. That means the needle, which has its own mass, inertia, there is some spring constant in the galvanometer. It will have so much of inertia that before it decides to turn and fluctuate, okay, it will hardly have any amplitude. So basically, it will fluctuate, but it will have so less amplitude that it will almost be on zero. So there will be many markings over here on that galvanometer. Okay, this will be the positive side, this will be the negative side. It will almost be at zero. That vibration will be so fast and that inertia will not allow it to go like this and like this. So hence, it will show zero current, which is nothing but the average value. So remember, galvanometer in an AC circuit measures average value, whereas the heat or the hot wire instrument always measures the RMS value. Keep this in your head, write it in your notes. Hot wire instruments in AC measure RMS value. Galvanometer, because of its inertia, measures average value. Keep this in mind. Yep. So this is how you need to do it. So Surya, there is a deliberate reason why I don't do that. Actually, there are two reasons. One is this board, first of all, does not allow me to do that. Okay, because this is Google Slides and it doesn't allow to save whatever I write in the PDF. Number two, I want you guys to check this video out and write the steps on your own and not, just look at the steps. Okay, this problem is done. Only when you write it on your own, then you will get it in your head, and preferably use this PDF as a workbook. So if you download it, you can write on it. I mean, you can take printout or you can use it like a digital notes using your pen or whatever. So that's the reason why I keep it, as it is. Okay, so 220 and 0, that's the answer. Okay, now let's go on to the next one. By the way, if you have any doubts, like say you have some questions to be asked, please make sure that you use our doubt app where you can chat with our doubt experts from morning till night. Okay, every day you can send a screenshot, or you can ask, sir, is this method clear, or how to solve this, give me a hint. So often it happens you want a hint, and you know that on Google, if you search for something, every site might say different ways or might give different answers. So please ask genuine trusted sources. So make sure you download the Vedantu app. There is a tab where you can ask unlimited doubts. There is no restriction on that. Please make sure you use that. Okay, let's go ahead to the next point. Yep. Okay, yes, let's get moving. Now here comes the next point. What is phasors? Look at this. Does it click? Do you guys, one second guys, my wire is stuck. One second. Okay. Does it ring a bell? Phasor. Now, this is a sine graph. It could also be a cosine graph if you shift it over here. And in a simple harmonic motion, we have seen that when a particle executes SHM, it is the projection or the shadow of a uniform circular motion. So when a particle is doing uniform circular motion, the projection is a SHM. And that uniform circular motion is a hypothetical thing, and that was called as the phasor of the SHM. Same way over here. Yes, Shivami says SHM. Alright, so here, if I have a AC current, I can think the value of this voltage is actually the shadow of a uniform circular motion. I'll tell you how. Look at this. Look at this animation. Probably it will make it very clear. Look at this. As this circular motion goes, okay, around, you can see the projection. You can see if I draw a line, it gives me the instantaneous values at every given point of time. You can see that. At every given instant, I will get the instantaneous value, and that exactly is nothing but a phasor diagram. So let me put it over here. This rotating line is called as a phasor. This diagram is called as a phasor diagram. Okay, and this is nothing but, you know, your voltage or current versus time graph. Okay, and you can see this one over here is the instantaneous value, which is also the shadow or the projection. You can call this, you know, as the shadow or projection. Shadow or projection of the phasor. Why am I calling it shadow or the projection? Think guys, if rays of light were coming from here, okay, if rays of light hypothetically were coming from here, these many rays will get blocked and only the shadow will be formed here. All this rays will go over here, and even from below, this much part will be the shadow. I hope this is clear. This will be the shadow. So the rays of light pass like this. This particular phasor will block it. The remaining light will go as it is. This will be dark, or this will be the shadow, which is also the instantaneous value. Okay, so phasor gives you an idea of the phase. Okay, it's a hypothetical diagram. It's an equivalent diagram. That's it. EGL. I have taught this in SHM, but still I'm repeating it. If you pay attention, EGL, you'll understand it. Yep. So now the next thing that you have to know is that if this phasor completes one revolution, this SHM also completes one cycle. This SHM also completes one cycle. So hence, understand, whatever is the angular speed over here, that angular speed, okay, that angular speed, that omega, which is for circular motion 2 pi by t, this t is nothing but the time period of AC. This is nothing but the time period of AC, or even the circular motion. Even the circular motion. We all know this from circular motion. 2 pi by time period is nothing but angular speed. And also the time period over here, one time period for this AC is also one time period for this circular motion. Everybody agrees to this point? Everybody clear? Very good, very good. Excellente, excellente. So a phasor diagram is a diagram which helps us visualize, the varying current in a circular motion format. That radius or that thing which rotates is called as phasor. The value is the height or the projection or the shadow, and the angular speed is very similar to angular frequency of that particular AC current or AC voltage. That's what you should know. You can see that. You can see it's very, very similar. One time period over here corresponds to one complete cycle over there. So this is the phasor diagram, that's the time diagram. So you should know the terms now. It's very simple, it's very easy. First of all, let's say this phasor diagram is rotating. Okay, this phasor is rotating. The length of the phasor, okay, is also the radius of the circle, which is also the amplitude of voltage or the current. Keep this in mind. It is the amplitude of the voltage or the current. You can see that because the graph went like this. So this was the amplitude. So that's the maximum value which you can get. So that's the amplitude of the voltage or the current. This is where it was initially. This was initial. Now this line, what is this line called as? I hope you remember this. This is called as the reference line. This is the reference line. The angle which it makes with the reference line, the phasor, that is called as initial phase angle. So angle between the phasor and the reference line initially is called as the initial phase angle phi. What is this phi? It is called as the initial phase angle. Keep this in mind. This is called as the initial phase angle. What is omega t? Omega t is the angular displacement. This is going in a circular motion. Omega t is nothing but the angular displacement. So omega t will be nothing but angular displacement. The total angle phi plus omega t. This is the total angle. This total angle is just called as the phase of the phasor at any time t, because as time progresses this particle will go here, omega t will change, so phi plus omega t will change. That's called as the phase of the particular phasor. That's something which you should know. Okay, I hope this is clear. Mira, I have already taught circular motion as a part of Flash series last year. You can still watch those lectures, but in this year, in Nurture series, I will start it probably after some time. Okay, so you need to wait for it. After work power energy, I will teach it. Okay, keep this in mind. Okay, so very, very important phasor diagram. So I have put up all the details over here. If I is equal to I naught, let's say cos or sin omega t, it could be anything, really doesn't matter. I naught is the amplitude. If I naught is the amplitude, it is also the radius of phasor. Everybody should remember that. If phi is the initial phase angle, it's also the initial position angular wise. Is the initial position angular wise. Omega is the angular frequency. It's also the angular speed of uniform circular motion. Omega is the angular speed of UCM, but in AC it is angular frequency. Remember, the word used is different. It's not called angular speed in AC circuits. Phi plus omega t is nothing but the phase angle, okay, which is the total angle with respect to the reference line. These are the things which you should know. Everybody clear what is a phasor diagram right now? Let me know guys by putting up a yo or a thumbs up in the chat box. Now, let's move ahead. Phase difference. Phase difference. What is this phase difference? Srimati, I'm not teaching for the droppers batch, but there is Aditya sir who is excellent in handling the droppers batch. He is teaching right now. The batch has just started this Monday. You can still join it for the V Pro 2022 for droppers. Okay? Chalo. Now, imagine you have voltage and current, but both of them do not start and end simultaneously. That's when things go bizarre. In AC, if the voltage increases like this, the current may not be like this. The current is not necessary. Why is it not necessary? You will understand it in the next class, where we are going to see AC with inductor, AC with resistor, AC with capacitor. You will see voltage and current will generally not go hand in hand. There will be some lag. One will be ahead, one will be behind. That's when the graphs will look like this. The blue one is voltage, the red one is current. That means if I had to think about a circular motion over here, and if I had to draw the phasors, think about it. Initially, the voltage is 0. If the voltage is 0, that means the voltage phasor will be over here. Correct? The voltage phasor will be over here because the shadow will be a dot. I hope you guys get it. The shadow will be a dot. But the current, if you notice, the current, actually if I extend it behind, it goes like this. Current already has some value. That means the current's phasor will probably somewhere be here, so that the projected value is already there. This much. This is that negative value which will be there. Now both of them will rotate. So think about it. This is voltage phasor, this is current phasor. Both of them will rotate like this. As they rotate, they will give you different values of voltage and current. Are everybody able to visualize this? Think about it. Everybody is able to visualize this. Think about it. So very, very interesting. Okay, so as the voltage and the current move around with constant angular speed, you will get different values of voltages and different values of current. Now, this difference that is there between voltage and current, this is called as the phase difference. Generally, the symbol for that is del phi. Very, very important. Something which you should know. Very good. In this case, voltage is ahead of current. You can see that. Voltage is here, current is here. Voltage is ahead of current. If current was here, voltage was here, this was some angle, it is rotating like this. Current is ahead of voltage. As simple as that. So that is called as phase difference. Okay. So you will see mathematically, you might see voltage is V naught sine omega t. Current will not be I naught sine omega t. It will be plus or minus some del phi. So that del phi represents the phase difference between voltage and current. Okay. In AC circuits, remember, voltage and current generally have, not always, generally have, some phase difference. We are going to study that, in the next class. But now let's start solving some questions. First question coming up on your screen. Okay, come on my warriors. Voltage and current in an AC circuit is given by this and this. Who leads whom by how much angle? Come on, figure this out. It's not at all difficult. Look at the functions, you will be able to get it. Who leads whom and by how much? Figure this out. Come on, my warriors. Figure this out. Who leads whom and by how much? Come on, come on, come on. Great, Archana. Rohan, if you're class 11th bacha, probably it's not a good thing to join a 12th standard class because there are so many concepts which you will learn in 12th which you don't know now. But there is nurture series. I hope, Rohan, you know about nurture series on this channel. Please watch the nurture series, okay? There is a class tomorrow also, bacha. That's the first class of work power energy. I've already completed till Newton's laws. I've also conducted so many revision classes as well. Please check it out. Acha. Okay, come on, come on, come on. Come on. So Trapti, there is an Olympiad level channel as well, which is called as the VOS, Vedantu Olympiad School. So, you know, over there you can definitely find Olympiad level stuff. But on this channel, we are going to restrict ourselves, at least for the time being, till JEE Advanced and basic level of Olympiad and KVPY. Yeah. So we are going to restrict it to that as of now. Okay. Chalo. Let's get moving to the next one. All right. Okay, let's see. So many of you got the correct answer. Very good. This is minus pi by 6. This is plus pi by 6. Think about it. Minus pi by 6 means the voltage will be below by 30 degrees. Example. And here the current which is there, it will be ahead plus pi by 6, which is plus 30 degrees. So what is the total difference? It is 30 plus 30, which is 60 degrees. And if it is going like that, then the current leads the voltage by 60 degrees. That's the answer. Some of you got it correct. Beautiful, beautiful. Okay, next question coming up on your screen. The instantaneous voltage at 3 terminals marked X, Y and Z are given by Vx is V0 sine omega t, Vy is V0 sine, oops, this sign has come twice. Okay, V0 sine omega t plus 2 pi by 3, and again this sign came out twice, ignore one of the sign, V0 sine omega t plus 4 pi by 3. Now you have connected a voltmeter between 2 terminals, X and Y, then between Y and Z, but the question is only find between X and Y. This part is going to be there as homework. Okay, you will be posting the answers later on. So what it means is there are 3 points, X, Y and Z. Now you are just measuring the voltage between X and Y. What is that voltage difference between X and Y? Come on, think about it. To measure RMS value, you have to measure what is the VXY RMS value equal to. Okay, I'll tell you what you should do. Big question, but it is not that difficult, trust me. Say, what they are asking you is voltage difference. Basically, del V xy is actually Vx minus Vy. Now, Vx is a sine function. This is nothing but V0 sine omega t. This is nothing but V0 sine omega t plus 2 pi by 3. Do you remember waves? Transverse waves, interference of waves. Isn't this like addition of 2 waves or subtraction of 2 waves? Do you remember that? And what you used to do when you had to add or find the interference of 2 waves? You used to use vector addition of the phasors. I hope you remember that. Vector addition of the phasors. That's all you need to do over here. So actually speaking, what you need to think is, if I draw a phasor of Vx, let's say it is V0, and if you draw a phasor of this guy, which is V0 plus V0 sine omega t plus 2 pi by 3, so maybe it will be here. Okay, the angle between them is 2 pi by 3, but you have to find the vector subtraction. You have to subtract these 2 vectors. That's all you need to do. So find the vector subtraction. That vector subtraction, if this is V0, this will be obviously minus V0. Adding these two will give me, okay, it's actually vector subtraction, which is vector addition, will give me del Vxy. As simple as that. Yep. So actually, whenever you have to add or subtract 2 sine functions, use vector addition, but in those vectors, the length of the vector is the amplitude and the angle between the 2 vectors is the phase difference. What is the phase difference here? 2 pi by 3. So guys, this is simple. What is the vector subtraction formula? Root of a square plus b square plus, not plus, minus 2ab cos theta. So it is a square is v0 square plus b square is also v0 square. Okay, v0 square minus, because it is vector subtraction, minus 2ab cos phase difference. What is the angle between them? 2 pi by 3. That was the formula. So what will this become? Check this out. This will become v0 will come outside. Inside the root you have 1 plus 1 minus 2 cos of 120 is minus half. So minus half. So minus minus will become plus. So it will become V naught root 3. I'll get it as V naught root 3. Everybody getting this? I'll get it as V naught root 3. But there is a catch. The question says find the RMS value. So this RMS value won't be this answer. Remember, RMS will be the amplitude, which is V naught root 3, the whole thing divided by root 2. So that's the final answer. Yep. So a lot of people forget that divided by root 2 and make a common mistake over there. So be careful. It's divided by root 2 because RMS has been asked. Now the second part is there as homework. I am pretty sure you will be able to solve it. Yep. Everybody clear? So I hope you will be able to solve this at home. The second part, I am putting it as homework. Okay, that's the answer. Now last question coming up on your screen right now. Here it is. This kind of question was asked in JEE Mains. This is a PYQ. Okay, this is more like a PYQ question. This was previously asked and this is very favorite question of all the examiners. So this current is given and find the RMS. Now, what is the method given in many books? The method in many books is as per this formula. So RMS current by definition is, they have, okay, you have to take the root. So root of integral I squared dt by t 0 to t. So they have integrated this. Okay, first let me put the root over here. Integrated 0 to t. I squared means I1 cos omega t plus I2 sine omega t whole square dt divided by t. Solve this and you will get the answer. This is the method which is given in most of the books. But don't do like that. That's very crazy. It's a very lengthy method. Instead, you can do one smart thing. How about writing this as this is like vector addition, guys. I'll tell you how. I1 cos, I can write cos as sine of omega t plus pi by 2. Can I not write it as sine of omega t plus pi by 2 plus I2 sine of omega t. Now I think of this like two phasors. This is, amplitude 1, this is amplitude 2, and they have a phase difference of 90 degrees, which is pi by 2, and you have to find the combination of them. So how do you do that? It's very simple. This will be I1, this will be I2, and the resultant, well, the resultant will be this one. So this is the resultant, guys. This is the resultant. How much will be the resultant? Resultant will be root of I1 square plus I2 square. Everybody clear till this point? Everybody clear till this point? What I have done? This is a wave. This is also another wave. This is a sine function. This is also a sine function. The outside part is the amplitude. I can treat them like the length of the phasor. The phase difference between them is pi by 2. So I have shown one phasor like this, other phasor at 90 degrees. So the vector resultant will give me the net amplitude. So this resultant is nothing but the amplitude. This is nothing but the amplitude of the resultant. So guys, the question demands us to find out RMS value. So what is RMS? It's amplitude divided by root 2. So just do that. So root of I1 square plus I2 square divided by root 2, which is root of I1 square plus I2 square divided by 2. Is it there somewhere? Yep, it is there. Option D. Option D. That's it. Isn't it interesting? So be careful that 2 is there inside the root. Yes, it's there inside the root. If you did it by this method, you're going to take a lot of time. So do not do this method. It is very lengthy. That's why I have taught you phasors. That's why I have taught you, phasor diagrams and how to add and subtract phasors. It becomes very simple using phasor diagram. So very interesting question. Option D is correct. This is the first question for your homework. Please note it down. You can also pause the video and you can take a screenshot. Please post the answers in the comment box. And this is the second question. First part we had already done. So find between Y and Z. That's the second question. Remember guys, my micro courses are starting on Monday. Okay, keep this in mind. I am starting electrostatics, current electricity, Gauss's law, capacitors, complete revision in my course, which is starting on this Monday. And how do you access it? Using vPro. There is a link in the description box, and we also guarantee you when you join vPro and attend all our classes, you will improve, and if you do not improve, all the money is returned back. Remember, you have an option to join the long-term batches in Hindi as well as English, unlimited access to micro courses as well as assignments and the tests. So all you need to do is, if you're watching this video right now, let me just show you where you can find it. For example, it looks like today my touch is not working for some reason. Okay, so if you go to our video right now, okay, so go like this, go below, I'll just pause this. Okay, 1 second guys, I think we went to some next video. Yep, let me just pause it. So you can see over here there is a KVPI crash course. If you want KVPI crash course for SX, that's for 12th standard, you can go there. There is a dropper batch link also here for 2022. There is also a link for 12th standard students. So if you are a 12th standard student, click the first link. If you are a dropper, click this one. Both the links will lead you to the full-time course for JEE 2022. If you are a dropper, make sure you click the dropper link. So you can see in this link over here, you are going to get the complete syllabus plus the revision plus other courses like my courses, topic specific short courses. Not just that, you will also be prepared for mains advanced with mock test till the end. You don't have to join separate test series. Vedantu is going to give you all the test series, booklet, everything as a part of this course. It's all inclusive, no prices extra. The only difference between light, classic and plus version is over here. See, if you want doubt solving on the mobile app after the class is over, then you go for the classic version. But if you want some personal mentorship, somebody who will guide you through timetable, how to sleep and when to study which and make a proper plan, how to cover backlogs, then you go for the plus version. A lot of students go for personal mentorship as well. Now, irrespective of what you choose guys, you know, you can see you can save 10% when you use my coupon code SHHPRO. That's very interesting. And the course price for the entire year is hardly 41,399. Yes, this is inclusive of everything. This is Doubt app included. If you take light version, it's barely 36,000 for the entire month. There is also an option to subscribe via EMI, so you don't have to pay entire amount. You can choose to pay via EMI option monthly also. Okay, that option is also there. If you want, you can try it out for 1 month, and if you do not like it, it's okay. It's fine. You can try it out for 1 month as well. Okay, just click on this link. It will lead you to, you know, log in, and you can put up all your details, and that's it. That's how you go. Every other detail that you would like to ask is mentioned over here. The timetable for physics, chemistry, maths, how our lectures are scheduled. It's in the evening. Okay, and whatever courses you are going to get, the details of that are also going to be here. In fact, it will be more than what is mentioned over here. Anything else that you want to see, it's all there. How many courses can you buy? Can I renew the 1 month plan? All the commonly asked questions are mentioned over here. Just check it out. Okay, so that's it from my side guys. I mean, I'm pretty sure you are now excited to at least join my course, which is going to start Monday. Remember, it's a part of this Vedantu Pro subscription. It's for free of cost only if you're a pro member. Okay, so for 2023, I'm not teaching in a batch, but I'm taking courses, separate courses, because there are already teachers who are teaching in the Pro, plus I'm teaching on YouTube. I cannot take so many batches, bacha, for NEET, JEE, again for 11th, 12th, and then dropper. But my special courses, those micro courses are available. Okay, you can still join it. Okay. So JEE Mains final attempt special recipe, probably, you know, we are just waiting for the results. Let's see when it comes. I know it has been delayed indefinitely till now because of, you know, the cheating cases which have happened. Till that time, do not worry or break your head over it. Please focus your attention and concentrate on JEE advanced preparation. Okay, so EGL, due to gaming and stuff, you're not able to concentrate on studies. First of all, delete that game and just keep quiet. That's it. Okay, so stop gaming. If you are having PS5 or Xbox, throw it out or give it to some cousin. That's the only way you can get rid of it. It's not like you can uninstall the game. If you uninstall the game, again you will install it. Just ban it, or ask your brother or your dad or mom to enter a password because there are these app restrictions which are available, you know, on mobile or even on Xbox and all of that. So put a password which even you don't know and ask them not to give it to you until you crack your JEE Advanced exam. So this is how you need to build up your mindset. You cannot you know, say that, okay, I think I can manage it, but no, again after 1 or 2 days, again you will get attracted towards the games or whatever your distractions are. So get rid of it completely and set up an ambition. Until I do this, I'm not going to play any games, and there are no excuses or relaxations for that. Yeah. So if you are distracted by TV, Uncharted, actually this is something which your family should be worried about. Your parents should be like, okay, it is distracting my kid. In fact, you should cut out all the cable. In fact, that's what happened during my preparation. My parents decided, okay, he has to study, so they cut off the cable. Only Doordarshan was there, nothing else. So there was no cable connection only. Like, they did not pay whatever that cable money for 1 year or 2 years as long as I was studying. So that's something which you should do. Or you should have a separate room without any disturbance, and whenever you try and watch the TV, your parents should be like, you know, don't watch it, you have to go and study, you cannot watch this program, or you should not watch this right now. So that level of balancing should be there. Okay. So Gunshap, you can watch what is KVPY. Just go to YouTube and search KVPY Shreyas Sir strategy. You will get a lecture. Every detail about KVPY, including the batch, I have mentioned. Okay, the batch details are there in the description box below. You can join the KVPY batch. What is KVPY? How much do you need to study? What are the colleges? What are the benefits? Everything is mentioned in that YouTube video. It's a big lecture. I cannot tell you in 30 seconds. Okay. Yeah. So guys, I'm really hoping on you guys. I'm banking on you guys. You guys are my next rankers. Please don't disappoint me. Please be regular. Please get your friends also along. Let's make this channel big. Let's grow together. And let's be very serious, because it is not easy to crack JEE Mains and Advanced. It's not just my teaching which will help you. So many other things are there, and I will be there with you for every hurdle that will be encountered by you. So guys, whatever comes, don't worry. I am there. If you find any difficulty, please put it up in the comment section. I'll definitely respond. And please post the answers for today's homework problems as well. Be regular, get your friends along, push yourself and push your friends also. That's how we are going to stay motivated, and we are going to crack JEE 2022. Let's nail it. And guys, thank you for tuning in today evening. Bye bye. This was Shreyas here, your physics master teacher. Hasta la vista.